The world is shrinking. There's a deep and relatively unexplored world beyond what the human eye can see. The microscopic world is truly alien and truly fascinating. I'm delving further than the microscopic scale. I'm going to explore the potentials of working at a nanoscopic level, working at a level a billion times smaller than the average scale we work at today. This is nanotechnology. Nanotechnology means any technology on a nanoscale that has applications in the real world. Nanotechnology is the science of building small, and I mean really, really small. It's pretty difficult to imagine how small a nanometer is, but let's just take a moment to try and wrap our heads around it. The tip of a pen is around 1,000,000 nanometers wide, so nowhere near close. A single sheet of paper is around 75,000 nanometers thick. A human hair is around 50,000 nanometers, was the size of a football. The coronavirus would be the size of an adult male. A donut would be the size of New Zealand, and a chicken would be the size of the Earth. In fact, on a comparative scale, if each person on Earth was the size of a nanometer, every single person on the planet would fit into a single car. A Hot Wheels car. You get the idea, nano is super tiny, we're talking subatomic. So that's how big, or rather small, a nanometer is. But why does it matter? Why look at really small things? Well, they ultimately teach us about the universe that we live in, and we can do really interesting things with them. When we move into the food we eat, the clothes we wear, the buildings and houses we live in, our own bodies. Now, think for a moment about how a car works. It's not only about having all the right parts, they also need to be in the right place in order for the car to work properly. This seems obvious, right? Well, in pretty much the same way, how the different atoms in something are arranged determines what pretty much anything around you does. With nanotechnology, it's possible to manipulate and take advantage of this, much like arranging Lego blocks to create a model building or airplane or spaceship. But there's a catch, and here's where things start to really get interesting. The properties of things also change when they're made smaller. Phenomena based on quantum effects, the strange and sometimes counterintuitive behavior of atoms and subatomic particles, occur naturally when matter is manipulated and organized at the nanoscale. These so-called quantum effects dictate the behavior and properties of particles. So, we know that the properties of materials are size-dependent when working at the nanoscale. This means that scientists have the power to adjust and fine-tune material properties, and they've actually been able to do this for some time now. It's possible to change properties such as melting point, fluorescence, electrical conductivity, magnetic permeability, and chemical reactivity, to just name a few. But where can we actually see the results of this kind of work? Well, everywhere. There are numerous commercial products already on the market that you and I use daily that wouldn't exist in the same way without having been manipulated and modified using nanotechnology. Some examples include clear nanoscale films on glasses and other surfaces to make them water-resistant, scratch-resistant, or anti-reflective. Cars, trucks, airplanes, boats, and spacecraft can be made out of increasingly lightweight materials. We're shrinking the size of computer chips, in turn helping to enlarge memory capacity. We're making our smartphones even smarter, with features like nanogenerators to charge our phones while we walk. We're enabling the delivery and release of drugs to an exact location within the body with precise timing, making treatments more effective than ever before. There's quite the list, and that's only a few of the potential applications. Let's delve into a few of these in more detail. Nanotechnology has been pivotal in advancing computing and electronics, leading to faster, smaller, smarter, and more portable systems and products. It is now considered completely normal for a computer to be carried with one hand, while just 40 years ago, a computer, infinitely slower, was the size of a room. This has been made possible through the miniaturization of the world of microprocessors. For example, transistors, the switches that enable all modern computing, have reduced drastically in the briefest amount of time, from roughly 250 nanometers in size in the year 2000 to just a single nanometer in 2016. This revolution in transistor size may soon enable the memory for an entire computer to be stored on a single tiny chip. Increasingly faster systems have also been made possible using nanoscale magnetic tunnel junctions that can quickly and effectively save data during a system shutdown. It's expected that using magnetic RAM, or random access memory, with these nanoscale junctions, computers will soon be able to boot almost instantly. Flexible, bendable, foldable, and stretchable electronics have been developed using semiconductor nanomembranes. They're monocrystalline structures with thicknesses of less than a few hundred nanometers. In normal terms, they're really small and super bendy. They're particularly useful for applications in smartphones and wearable technology, like smartwatches. Nanotechnology is a definite answer to a digital world that is focused on becoming smaller and more efficient, but it can also help us start to clean up some of the world's bigger and more pressing problems. There are many applications for detecting and cleaning up environmental contaminants. It is anticipated that nanotechnology could contribute significantly to environmental and climate protection by saving raw materials, energy and water, and reducing greenhouse gases and hazardous waste. From increasing the durability of materials so that they last longer and reduce waste, to the creation of insulation materials that improve the efficiency of paper towels, allowing them to absorb 20 times its own weight, nanotechnology really has the potential to do great things for the conservation of our planet and the human race. The availability of fresh, clean drinking water is an increasingly pressing issue that can be linked back to population growth, urban mitigation, pollution, and the vast effects of events associated with climate change. Nanotechnology holds the power and promise to not only detect pollutants, but to filtrate and purify. The magnetic interactions between ultra-small specks of dust can remove arsenic. This is incredible, given that it is naturally present at high levels in the groundwater in a number of countries. Similarly, the development of nanoparticles that can purify water pollutants, which cost less than the process of pumping it out of the ground for treatment, also holds a great promise. Basically, getting clean water is a huge problem, and nanotechnology can help solve it. This all sounds almost too feat once achieved.
Hey,